2019 Higher Level Technical Graphics Junior Cert exam paper. Okay, in this section we have a total of 15 questions and you have to answer any 10 questions. Okay, so question 1. First one here is a tangent, second one is a chord, a sector and a quadrant. So you just basically use these to fill up those 4 boxes. Perspective. Okay, so we have 2 vanishing points, VP1 and VP2, and all my lines have to vanish back to those. Okay, so we do a little bit of construction work first. So we draw in those lines here, disappear back everything we need, back to the vanishing point. That makes sense. Okay, once we have that bit of construction work completed, we can see that this one dropped down, vanished back. Cutting this one gives me a point, and that is my first line. Okay, vertical lines will stay vertical, so here I come straight up until it hits this line, and that allows me to heavy that. I then disappear that back to vanishing point 2. Okay, we disappear that back where they cross, gives me a point. From here I extend up. I can use this little graphic here to help me. And that's that one completed. Question 3, a little bit of calculations in this. Okay, so first and foremost, we can see that this is radius 15, so diameter 30. Same with this one. Okay, these are 2 pentagons, so we know that the external angle needs to be 72 degrees. Right, so A, the length of A is the diameter of one of those circles, which is 30. And B, so the distance from here to here. Well, we know that the overall length from outside to outside is 74, minus twice the diameter, which is 60, leaves me with 14. So that total length there is 14. So it's half and half, so it's 7 and 7. Okay, so 14 plus 15 gives me 29. So B is 29. And as I stated earlier on, external angle of a pentagon is 72 degrees. And then a straight line has an angle of 180 degrees, so 72 from 180 will give me 108 degrees. Okay, question 4, an isometric. So I did a little bit of work on this beforehand, but basically what you do is you count your boxes. Okay, so from here to here is a total of 7 boxes. So from here, 1, 2, 3, 4, 5, 6, 7. So I know that that's the top surface. Okay, we know that that length there is 1, 2, 3, 4, 5, 6, 7, 8, 9 long. So that's where I put in my 9 line here. And it's 1, 2, 3, 4 wide. So 4 wide. Okay, and then we complete our rectangular surface at the top. Then from here I come down 3 over 1. So down 3 over 1. That gives me that position of that. Same on this side, down 3 over 1, which is actually there. And then we just complete that full unit there. Okay, and then for the legs, okay, we're in 1 and it's 1, 2, 3, 4, 5 wide. So 1, 2, 3, 4, 5 wide, and then it's up 1, 2, 3, 4. So from here come up 1, 2, 3, 4 and in 1. So that's in underneath, so we don't see it. So we create a construction line, but we only heavy in what we need. Same here, up 1, 2, 3, 4, in 1 gives me the point, and then we draw that in. And we complete our graphic. Okay, and you can do a little bit of shading then, because it says color or shade, so make sure you pick up those easy marks. Okay, question 5. Shown is a graphical puzzle consisting of squares, rectangles and triangles. Count the number of squares, rectangles and triangles. So how many squares are there? So there's one overall one, 1, 2, 3, and 4. Rectangles. So we have 1, 2, 3, 4. And then do we have any more? We have this one, 5 and 6. Triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, question 6. This is a rotations question. So you get your compass. We want to rotate our point E up until it hits the line L. My rotation point is the point O. So put your compass on O, measure to E, rotate up. Okay, we then join that point back to O. That angle is the rotation angle that everything needs to be rotated by. Okay, so that's where my new point E is. So I'm going to get my protractor and I'm going to measure that angle. So that angle appears to be 26 degrees. Okay, so 26 degrees. Right, so D brought back to O, measure 26 degrees. Draw my line out. And then we put our compass on O, measure to D, and rotate it up. So that's where my new point D is. Do the same with C. So join C to O, rotate by 26 degrees. Draw in my line and rotate C onto that point. And that gives me my new point C. Okay, and then finally we do the same with B. Join B to O. Run my protractor along that line. Measure 26 degrees. Tip of the compass on O. Measure to B. And rotate it around. That's where my new point B is. And then finally do the same with A. A already has been joined to O. Measure 26 degrees. Draw out my line. And rotate A down. So that's where my new point A is. Once you've that completed, you can heavy in your new shape. So I'm just using a different color there, which makes it a lot easier to visualize it, and it stands out better. So a good idea in the exam to do that yourself. And that's the new position of it, rotated upwards. Right, question 7. This is what we call an auxiliary. Okay, so we're looking in at this object from an angle to see and if we can find the true shape of surface S. So what I've already done is I've projected all my lines perpendicular to the x1, y line, x1, y1 line, which is my auxiliary line. I then get my heights from elevation. So I only need 2 heights really. So that height there is the overall height, and then the height of the underside. And once you have those, you can use parallel lines. Always make sure to have a look back over it. Is there any hidden detail needed? No, there's not. But that is the true shape of surface S. Next one here is a little bit of a freehand, so I'd always kind of draw it at 30 degrees, so we're used to drawing an isometric. So draw your shape pretty much isometric. A tape measure coming out. When you're drawing in isometric, always make sure that vertical lines stay vertical and your angle lines run parallel. Okay, and again it says color or shade the completed sketch. Just put in your offset shape there on the side as well for completion. And then it is important that you color or shade it. Again, you don't want to be throwing away simple marks by not finishing off answering the question. So once you do a bit, you can't be penalized. I would always put in a horizon line as well to give it a bit of step. Okay, question 9. So this is where you have your CAD commands. Okay, so from SolidWorks, the CAD commands will be the ones that I normally use in this section, and you get full marks for that. Okay, so here, moving from this view to this, you're just sketching a little bit of a line. Okay, so it's sketch line. Okay, here we have a center line, and then you've mirrored it about that. So it's the mirror command. We've offset as the same shape in a small bit, so that is what we call offset. And then from offset, to give it a three-dimensional view there, we're now extruding, so extrude. Okay, question 10. Okay, so we have a parabolic curve. Okay, so we have a left rectangle and a right rectangle. Okay, so ABO. Okay, so this rectangle here, we have a height of 55 and it's a width of 30. So 55 and 30 are both very easily divided up into 5 equal parts. Okay, so 55 divided by 5 is every 11. So every 11 millimeters, I'm going to create a mark. So 11, 11, 11, 11. Okay, the vertex is at O, so that's where my diagonal lines are going to be originating. Okay, so I'm going to create my diagonal lines. And because I divided the height up into 5, I need to divide my width up into 5 equal parts. So 30 divided by 5 is every 6 millimeters. So every 6 millimeters, I have my marks there. Okay, so now what we need to do is we bring the first one onto the first, second onto the second, third onto the third, and fourth onto the fourth. And that allows you to create your parabolic curve there. Okay, and we do the same on the other side. I'd pre-measure those, so I'm not guessing. I measured them before I did the video. Again, first onto first, second onto second, third onto the third, and fourth onto the fourth. Okay, and that's that question completed. Question 11. Okay, so here we have a development of an object. Okay, and we need to identify which one it is. Okay, so as we can see, we have the two sides. We have a front piece, the bonnet, and then the upright piece. Okay, and we have a back piece. So B is the only option because A doesn't have that back piece and C doesn't have that bonnet. Okay, so that's why we know what to say. Okay, question 12. So question 12 is a circles theory. Right, so what we have is we want to create an internal tangent between those two circles like that. Okay, so a tangent is a line that touches a circle at one point only. It doesn't cut through it. Okay, so we need to look at this question and we need to remember what our theory is. So the first thing we always do with circles really is we join the center points. Okay, we then bisect that line. So set your compass to more than half, swing an arc, and swing an arc. The two arcs across gives you a point. Join those 2 points. So that is the center point of the line. Draw in a semicircle. Okay, in this question we need to find our tangential line. Okay, so we have a circle radius 100 and we have a circle radius 20. So what we need to do is we need to add those radii. Okay, so 20 plus 30 or plus 10 gives me radius 30. So set your compass to 30. Dip your compass there and draw in a circle around that. Okay, that gives me a point out here and we call that point X. Join X to the center. And where it cuts gives me a point of contact. We then create a parallel line on the other circle on the other center's point. So slide along. And there's your parallel line. Okay, and that gives me a point of contact there. We join the 2 points of contact. And that gives you your tangential line. Okay. Right, question 13. Question 13 is in enlargements and reductions, which I normally don't do with my classes. Okay, so question 14. Okay, the graphic shows a set of steps. Draw a well-proportioned freehand sketch of the plan. So it's very important words there is that it's well-proportioned and it is freehand. So what I would always do is I'm going to start off with my back and then I'm going to draw a line here. Okay, so this side here is shorter than this. So the other side I'm going to extend it a little bit more. Okay, we have 3 steps, so I'm going to evenly divide that line up into 3 equal parts visually. So you're visualizing that yourself, and then I'm going to draw in my 3 lines there. Okay, there's a curve here, so a freehand curve in like that, and there's also a curve here, so a little bit of a curve there. Okay, so once you have it drawn, you can then rub out that little bit there, because we don't need it. And there's your well-proportioned plan view of that. Okay, question 5. First thing we need to look at is this point here is January. It's up 50, so that point is 50. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 50 divided by 10 is every 5 millimeters. So each one of those is 5 millimeters. So I'm just going to write them in nice and clearly. Okay, so I'm going in 5 millimeter increases. Okay, so February is 30, March is 55, April is 15, May is 25, and June is 45. Okay, and then complete the chart to represent this form. So you do need to draw those in. Okay, I'm drawing them in freehand there now, but it'll probably be better to draw them in accurately with your ruler. Okay, and that's question 15. So as I said, from that paper, out of 15 questions, you need to choose 10.